So what is a polygon? Well, first of all, it is a planar figure, which means it is two-dimensional and it is a closed figure. It must have straight edges. So even though we learned about circles when we were small, along with these other shapes, they are not polygons. They must have straight edges. And finally, they cannot have crisscrossing lines. What that really means is that each segment can only meet one other segment. You couldn't have something that was similar to this shape, like an hourglass. So here are examples of a whole bunch of different sorts of polygons. Each one is flat, it's closed, and it has straight edges. So what types of things aren't polygons? It can have straight edges, but this is an example of a polyhedron. It is not two-dimensional, so it doesn't qualify. This also, you could also say it's three-dimensional, and I would understand that means it's not 2D. All three of these are examples of items that are not polygons. This one here has a curved edge. This is what I mean by crisscrossing lines. This point here is what's stopping it from being one polygon. That is two separate triangles. And this one is not closed. Polygons can be divided into two different categories, convex and concave, or non-convex. And convex polygons are polygons where all the vertices are pointing outward. And this means that like an ordinary stop sign or the school crossing sign, those are convex. All of the interior angles are less than 180 degrees each. At each corner of your polygon, the inside angle is smaller than the outside angle. In case you want to have an example of each type, every polygon on this page, with the exception of this magenta one, every single one is convex. And so if you just jot down a little example of one or two, it may help you. So let's take a look at what makes this concave. So a concave polygon has at least one of the vertices is caved in, or it points inward. So the interior angles at these vertices would be more than 180 degrees. It would be like a reflex angle. Now, this is an example of a non-convex or a concave polygon, because this angle at V, the inside of it over here is greater than the outside. It's greater than 180 degrees. So what do we call these shapes? Well, if you don't know the name of it, you can always call it just an n-gon. So if it's a five-sided shape, you could call it a five-gon instead of a pentagon, and technically you would be correct. But you want to take a moment to pause and write down the proper names of the shapes. I want you to note that these are Greek prefixes, with the exception of triangle and quadrilateral. So instead of saying sept for 7, we use heptagon. So you can see that it only goes up to 10. Well, they're going to use dodecagons are a thing, and we're going to use them all the time now and a lot in the next semester as well. So I want you to see the first one is convex, but all of these concave shapes are totally still dodecagons. They're 12-gons. So what about an 11-gon? There are several names, but the preferred name is the Greek name. So let's take a look, and it is called a hendecagon, as you can see. So a hendecagon is an 11-sided polygon. So the preferred name is a hendecagon. So flip over your paper. Let's look at the backside for some information about what makes something a regular polygon. At the bottom of the page, we're going to take a look. Regular polygons are just polygons that have congruent sides and congruent angles. They must have both. So they are both equilateral and equiangular. You can see they gave you an example of things that aren't regular polygons, just to let you know it's not enough for all the angles to be congruent or for all the sides to be congruent. So if we use our familiar rectangle and rhombus, the only regular quadrilateral would be a square. It must have congruent angles and congruent sides. So we're in the home stretch now. Up above, we have this angles of a polygon. We're going to fill in part of this chart together, and I want you to finish it off and bring it to class tomorrow. One column is about n, that's the number of sides. The next one asks you about the number of triangles that are in the shape. So let's just take a look. If you have a triangle, if I draw a triangle, there's only one triangle there, and you'll see what I mean in just a moment. So the difference between n and the number of triangles, 3 minus 1, is 2. If you have one triangle, how many degrees are in it? 180 degrees. So we're going to fill in this entire chart. You can even fill in the final column, because now that you know what a regular polygon is, if there are 180 degrees in that triangle and there are 3 angles in there, can you tell me what each angle is equal to? Now for filling in the chart, let's take a look at this next part. You can see I have a little quadrilateral drawn on the side. So over here, we have the quadrilateral. You're going to pick one corner and draw all the diagonals you can. How many triangles did we get? 2. If we do the difference for the number of sides minus 2 triangles, we get 2. Curious again. If each triangle has 180 degrees, that's 360 degrees total. Now, why do I have this dodecagon here for you? You can skip all the way down to 12 now. This is what it means. If you do not need to draw this picture, first of all, I want to let you know. But if you drew a dodecagon, you would pick one vertex and you would draw all the diagonals that you could from that vertex. So here we would have each line we would draw to each corner. And you can see, oh, there are 10 triangles in this shape. If there are 10 triangles and each triangle has 180 degrees, it should make sense to you that there are 1,800 degrees in this, 180 times 10. So I want you to use what you know, fill this in, and we already did 12, and you can notice that you're going to notice a pattern. Partway through this, you're not going to have to do any more work. You're going to be able to just fill it in as you go along. So take what you know, bring your questions to class, and we're going to fill in the rest of the information there.